All right, now suppose we're given a normally distributed population, and we're given that mu, the mean of the population, is 120, and the standard deviation is 4.1. And we're asked to find the probability that x is less than 115. So we're working with a normally distributed population. So there's our normal curve. Z scale and the data scale. We know where this is centered. The center of this is the population mean. And I'm just going to place the standard deviation here, so we roughly know where to look to find it when we need it. What's that, 4.1? All right. And we want to find the probability that x is less than 115. And so our task then is to label 115. Remember, what we're doing here is just sort of a brief brush-up review from what we've talked about before. So we need to place 115. There's 120. We know this is the number line, so 115 goes to the left of 120. 115 goes to the left of 120. This is the x value in question. So we want everything to the left of that. Well, so it corresponds to finding this shaded region. All right. So that means, what do we need to do? We need to translate from the data scale to the standard, the z-scale. And then from that z-score, then we can compute the table value, which gives us that probability. We're asked to find the probability of being less than 115, which is this shaded region, which corresponds to this shaded region. And remember, this arrow always goes left. Our table is designed to be a left-hand table, so whenever we look up a value from the table, that number from the body of the table goes on this arrow to the left. So what's the procedure now? So we need to find z. Now we have two formulas for our z-score. We have a choice. We have z is equal to x minus mu over sigma, or we have z is equal to x bar minus mu over sigma over the standard deviation. So the question is, which of these two formulas do we now use? Well, we need to choose the value that does not use the x bar. We are on the x scale, the raw data scale, not the mean of the sample. We have taken a single data value from this population. We have not taken a sample of size n. And so because we're using only the data scale, we've not taken a sample from a population, we're not using this z-score, we're using this original z-score. Usually the tip-off is one of two things, or in combination. If we have taken the mean of a sample, then this is the formula we're going to be using, and this is the x bar scale. Typically that will align with the fact that we've taken a sample from the population. Notice there's no sample here. So we're using this first z formula as the computation for our z-score. So we need to find our z-score is equal to x minus mu over sigma. In our case, our x value in question is 115 minus the mean of the population is 120. And we're using this first formula, we're using sigma. Sigma is known to be 4.1. And so now we erase for our calculators. And what do I have here? I have 115, subtract the 120, and divide by the 4.1. And so this approximately is equal to negative 1.219 yada yada, which we will round to using negative 1.22. So our approximation for the z-score, negative 1.22, is our z-score. And And from that, we find the table value. Well, we have our table. Our value we want is negative 1.22. All right, so let's zoom in on that a little bit. We want negative 1.2, and then we want the 2 column, the second decimal we want to be a 2. Negative 1.22. Our value is 0.1112. 0.1112. 0.1112 is our table value. The table value, let's zoom back out, 1112. Table value goes on the arrow. In this case, the arrow and the shaded region does in fact match the region we're looking for, the less than region. Since everything matches up, this is our final result. We don't have any arithmetic to do. So the probability that x is less than 115 is given by the table value 1112. All right? Let's see if we can play number 2. We want to find the probability that x is less than 104.1. Now something's going to happen here that has not happened before, and I'm doing this on purpose so we know how to handle it. So, same procedure as before. Again, we've not taken a sample. This is a normally distributed population. We've not taken a sample. This is a single data value. We've not taken a sample of size n. We're not talking about a mean, so this is the same original formula as before. We're using this same formula. All right, we know where mu is. Mu is known to be the population mean. All right, mean is 120. Standard deviation is 4.1. All right. And we want to find probability that x is less than 104.1. So z is equal to x minus mu over sigma, the same formula we're using whenever we do not have a sample. We're not taking a mean from the sample. So this is straightforward. This is the data scale, standard scale. Where is 104? 104 is over here somewhere. We want everything less than 104. So this is very similar to what we were doing before. Arrow goes to the left. All right. So our x value in question is 104. Minus mu, the mean is 120. All over the standard deviation is 4.1. So let's go to the calculator. I have 104 minus 120 divided by 4.1. And I'm going to have this as negative 3.90 is an approximation we'll use. Negative 3.90. Table value. And now you're going to see, when you look this value up in the table, you're going to see why I'm working through this specific example, this specific item. Let's see what we got here. All right. All right, we need a table value for negative 3.90. So let's see if we can find the value we need. It's negative 3.90. And when we look up negative 3.9 on our table, our table doesn't go far enough. Negative 3.4. Negative 3.4. The question is, what happens when we go beyond what this table will afford? We will do this. This is not universal. This is not every course this happens in, but we will use this method for our purposes. Anytime the z-score is more than this table will afford, we can use negative 3.40, negative 3.41, negative 3.42. The largest our table will do is negative 3.49. Any z-score bigger than negative 3.49, for our purposes, we will use, instead of using the smallest value here is 0.0002, anything beyond that, we will use 0.0001, no matter how far. So, our table value is negative 3.90. All right? That is beyond what our table will use. Anything beyond negative 3.49, we will use 0.0001. If you go to a different course with a different instructor, they might handle this slightly differently, but this is how we're going to work this problem. And so our purposes, the table value is 0.0001, and from there you proceed just as usual. From there, you proceed, take this number, put it on the arrow. In this particular case, that matches the area that's shaded. So the probability that x is less than 104.1 is equal to 0.0001. This is now a rough approximation, but for our purposes, that's sufficient, and that's how we will handle this. Also notice it's possible to be beyond the edge of the table in the other direction. The largest value our table will use is positive 3.49. So again, anything beyond that number, we will use, instead of 0.9998, anything larger than 3.49, we will use 0.9999. No matter how large, no matter how far, for our purposes in this course, anything beyond 3.49, we will use a table value of 0.9999. If your z-score is 5.2, we will use this number. If your z-score is 3.88, we will use that score. If your z-score is 6.23, we will use 0.9999. Anything beyond 3.4, we will use 0.9999. Anything beyond negative 3.49 negative, we will use 0.0001. Again, no matter how far, no matter how much, how further beyond this value, we will use 0.0001 on this end, and we will use 0.9999 on this end.